Hello, you're watching the Open Telco Infra Summit, part of our year-round DSP Leaders coverage. I'm Guy Daniels, and today's discussion looks at the evolution of the Open Mobile Core Network. 5G standalone calls for a new architecture for the mobile core, one that embodies cloud-native principles. But how is this open approach different from the legacy core? And why is this transformation moving so slowly? What's inhibiting its progress? Well, joining me on the programme to discuss the benefits and the challenges are Amith Maharaj, who is Group CTO, Network Design and Planning for MTN. José Antonio Martínez, who is Core Network and Platforms Technology Global CTIO at Telefónica, and Ajay Thakur, who is Technical Steering Team Lead for the SD Core project at the Open Networking Foundation. Hello everyone, it's really good to see you all. Let's start first of all with some background, and I'd like to ask, how is the 5G SA core evolving from the legacy EPC architecture that we have? And AJ, perhaps we could come to you for comments first.
Yeah, so 5G standalone represents a significant shift from the traditional EPC architecture. There are really 4 to 5 building blocks how the 5G architecture is distinct from the corresponding legacy EPC, right? So it's very hard to say like from where to start, but let me start from the one of the main area, which is the service-based architecture, which helps to make sure that each and every network function is giving some specific service and their APIs are defined by 3GPP. So what it means for the operator is that like it's very easy for them to plug and replace it with any other network function from any other vendor. It's very easy, and it's very easy to deploy and test. If I go for the next one, next is the most important aspect of the 5G is the network slicing. In the 4G era, like when operator wanted to deploy any specific application, they had to really recreate the whole network and then realize that new service, right? But in case of 5G, we have the option of creating the network slices very easily. So it gives the operator time where like in a very short amount of time, operator can design the use case or solution and start the operation right away, right? So that's about the network slicing. The third thing goes about the building the standard with the virtualization in the mind, cloud native and virtualization, right? So most of the specification what a 3GPP has defined, they have clearly in their mind that this software is going to run on a virtualized off the shelf hardware. So there is no legacy hardware required to run the 5G. So that gives the benefit for operator to use their existing hardware inventory and run the new cloud native 5G software on those hardware and recreate the network in a very short amount of time. The fourth most important aspect I can think about the edge computing. So 5G brings in a lot of use cases where edge computing it's going to be very easy for operator to bring the to onboard the use cases where we need the user plane functions which are closely located where the device is generating the traffic, right? So there are few points which 3GPP has brought up, like which is called as a branching point or the user plane function chaining. These are really unique. These are really unique features in the 5G. And then they are very, very useful for operator to bring those solutions. And last point, I'll just briefly touch upon, like 3GPP has addressed a lot of security concerns, especially around the SIM card security or IMSI, which is the identifier for the device. That is one more long pending concern is addressed by 3GPP. So, there are many features. it's very hard to pick which one is the topmost, but all these collective features makes 5G architecture a very unique and different from the 4G.
Thank you very much for that, Ajay. And as you articulated there are significant changes from what we've had with the on the fourth generation of mobile with the EPC. Amith, would you like to come in and comment on this move away from our legacy architecture?
Yeah, thanks, Guy. I think one of the key other areas that is changing fundamentally is the charging interface. So the move away from the GX and GY interface towards the SPI now is a big move. That's also going to warrant a change to the charging function as well. So you would need to do quite a big upgrade on the charging function or your online charging platform to be able to cater for this new move away. Obviously, the SPI, as Ajay alluded to, adds a lot more openness to the platform, allowing for multiple different suppliers to provide different function sets to make it more kind of an open kind of solution. And then lastly, the elasticity as we move towards the cloud native, the elasticity, the ability to have a stateless core network is quite an important step forward as well.
Thanks very much, Amith. And if I could just stay with you for a moment, because we've looked at the move away from the legacy, but what would you say are the main drivers? We've outlined a lot of the architectural changes, but what's pushing this change? What are the drivers for an open core network?
So Guy, I think one of the key things is having a group of companies under MTN Group. We have about 18 different markets. And so far, we almost, in the past 20 or 30 years of operation, haven't changed core networks within these markets, purely because, number one, it's not a traditional revenue generating source, because the core network performs, although it's the heart of the network, it doesn't contribute towards new revenue generating opportunities. Now I'm talking more about the legacy, the core networks. And therefore, always money was pushed towards the radio network, where you increase coverage and directly increase revenue. So the incentive hasn't been there. So you have a lot of lock-in. You do not have a lot of flexibility in terms of license charges. Hardware does not scale. So you kind of really tied in and have to spend a lot of money in the past towards legacy providers, where the hardware and software are kind of embedded. With this move towards disaggregated hardware and software solutions, including the open core drive, they create some flexibility for us to kind of reduce that lock-in. It also, definitely will result in a reduction of capex. And lastly, the ability to, once the hardware is procured being standard hardware, the ability to swap out a core vendor if for non-performance or let's say cost flexibility, that ability is there. So those are the key drivers. And I think the next part is the whole new dimension towards this SPI or service-based interfaces that get created, that allows you to bring in many different suppliers at once, because it's standards-based. The ability to add suppliers who are more flexible, maybe in one part of the network function, as opposed to maybe your traditional legacy core network supplies.
Great. Thanks very much for going through those and just really emphasizing the importance of disaggregation. And as you mentioned at the end, SPA architectures that are getting introduced. Ajay, you'd like to come in on this question and give us your thoughts on the drivers for this change?
Yeah, so as I stated in the first part, since 5G really talks about the cloudification and virtualization of each and every network function, right? So it has given a very easy access with the very basic commercial off-the-shelf hardware. Anybody can take the open source code, build it, and run to get the feel about it, right? Like how it works, right? So what I have seen, at least based on my experience, is that there's lot of interest from the academia now, because they have easy access to code. They want to do a lot of experiment or research on this 5G network and maybe beyond 5G, right? So it's like they are able to carry out their real research on the real 5G network, which is developed based on the 3GPP standards, right? So I see a lot of interest from academia. The same level of interest I don't see in the 4G, but that there are multiple projects which see the lot of contributions coming from the students and professors, right? And it also helps many vendors to take this open source software and then see how their solution is able to easily integrate it with the open source software, right? So there is a good ecosystem about the developers, integrators, and service providers. So they are also driving many more open source core network projects.
Oh, that's great. That's a really interesting aspect to this change that maybe we don't always talk about. Thanks for that. Let's move on, because I'd like to look at what it really means to upgrade the core network. What are the practical considerations for telcos? And José Antonio, let me come across to you with this one, because what do telcos and their partners need to consider?
Yeah, I think there are several practical considerations that the operators could take in mind. In Telefónica, the first practical consideration is to have a full convergent core solution, not only supporting 5G SA, but also 4G, for example, and 5G NSA. The reason of that is because we have a lot of advantages. We have reduced signaling between control plane network functions. The mobility between the different access technologies is basically internally assumed by the network functions, which also means lower footprint because we don't depend on external interfaces. Furthermore, as my colleagues have commented, 5G core is built based on cloud-native tools and CNFs, microservices. So having this convergent core solution, we can take advantage of all these benefits of cloud-native environments, not only for 5G, but also for, in the case of 4G, for example. Another benefit of that is that we have a simpler O&M, because at the end of the day, we are operating just one single product instead of different products depending on the access technology. Other practical consideration from my point of view that we should consider is the redundancy. We are building 5G core based on different clusters with the intention to isolate different areas in case of any issue to impact only this cluster, leaving the rest unaffected. So this is other consideration we need to take in mind. Furthermore, other relevant practices to go directly to an ecosystem in which we deploy containers over bare metal. We have seen different advantages against virtual machine deployment. Basically, we have a reduced footprint because we are removing the hypervisor and the guest operating system. And apart of that, we have a simpler stack because we don't have this layer at the end of the day. And last but not least, I will say that Kubernetes introduction has accelerated the lifecycle management, and also the SVA architecture has introduced a higher number of network functions. So we need to be more flexible, more efficient in the way we upgrade our networks. So one key tool for us is to consider CI/CD tools and in-service software upgrade features to ensure we are automating the deployment and testing of our network, which means to simplicity in terms of from an operational perspective. So I would say these are the main practical consideration we could consider.
Thanks very much, José Antonio. It's a challenging environment for telcos, and we covered this a couple of months ago in our Cloud Native Telco Summit, especially on the CI/CD aspects of this. Amith, I wonder if I could quickly come across to you and just ask you a question related to this, because when you have a group structure, is it more difficult for you to make this change and evolve to a new open core network, or is it actually simpler because you've got scale that could help you?
Yeah, look, definitely scale helps a lot. We've just gone towards a full, let's say, a refresh across. So we skipped the VNF model and we went straight from PNF towards the cloud native now. So we halfway through our 3-year program of modernizing the core across the group, but it was done in one process of finding the right vendors for each of the markets. But I also just wanted to add a little bit to what was said. One of the other drivers we often is one of the most important in our markets are the business drivers for some of these the use cases that business would like to deploy, be it private networks, be it low latency applications. So that's seen to be a key driver towards the 5G standalone core move.
Great, thanks very much, Amith, for those comments. Well, we talked about the drivers, we talked about the practical considerations. Now, how do telcos get help here? Which are the communities or the open source projects or the cloud native tools, what are contributing to this open core infrastructure? Ajay, can I come across to you first for your comments? Because given the work you're doing at the ONF, I think you're in a good position to help us here.
Yeah, sure. So there are many organizations or research institutes who have been participating in this open source core network projects. So I will just name a few. So one of the leading organizations is Open Networking Foundation, where I'm associated with. We do have projects about the private 4G and 5G. It comes along with the private 4G and 5G. It gives the tool chain about how we can integrate it with the CI/CD, like open source CI/CD projects, and how we can make this deployment successful in a very short amount of time. So that's about the Open Networking Foundation. There's other organization like Open Air Interface. They have the software defined radio, as well as they have the 4G and 5G core network functions. And it's as I said, like this is like open source. There's one more leading organization which is like Free 5GC. They have been like the one of the early starter on giving the free 5G code to the most of the community members. Like they have been the inspiring organization for many people to start these free 5G projects, right? Then there are, like, to name some more, there is like Open 5GS, then there is a Magma. So there are many projects, and I'm sure I have not counted all, right? Most of the projects, they depend on what kind of license they offer on this software, whether that is like commercial friendly, whether it's Apache based license or whether it comes with the GPL, right? So license probably sometime is one of the most important factor when somebody is contributing to the open source, right? And all these open source software as of today, they tend to use Kubernetes as the one of the foundation container orchestration platform. So CNCF plays a lot more important role in providing the tool chains for all these open source software. Yeah.
Yeah, indeed. Thanks very much for that. And José Antonio, can I quickly come back to you? Because in your previous answer, you mentioned the importance of Kubernetes and some of these cloud native tools and methodologies you're using. Do you find you have all the tools you need to undertake this work, or are you still developing or co-developing tools to help you, or is it all there in the industry to use?
Yeah, no, totally agree. Actually, thanks to the fact that the industry has adopted Kubernetes as the standard solution for building 5G core solution, we are building a more interoperable system. And aligned with my previous comment of CI/CD, we are taking other open source projects. For example, for building the CI/CD pipeline, we are adopting Jenkins open source project, which is key. Also GitLab, Grafana, Kibana for data visualization. So at the end of the day, there are many projects that we are adopting to build the full ecosystem. I would like also to mention other relevant community that is Camera Alliance from the Linux Foundation in association with the GSMA. Well, not only the operators take part, but also the developers. So it is a common alliance where we take the services requirements to exposure the network capabilities in order to offer APIs that the developers could use to improve the user experience and the services that they will offer. So I think this is really important for us to participate in this community, because at the end of the day, if we define common practices, we will be able to reduce the development efforts and also to ensure the ecosystem is interoperable. So this is really, really relevant for us.
Thanks, José Antonio. And let me go back to Ajay for comments, some extra comments here. Ajay.
Yeah, so I just want to add some more thing here is that we should not just focus on the actual cloud like container network functions which gets deployed in the network. There are many tools available, open source tools available in the GitHub, which can be used to test your 5G network functions, right? So I am being one of the author of one of the tool, which is very easy to just spin up and test your 5G core network to some extent, and it's very handy. So I want to tell that like what our open source community is doing, that's equally applicable or equally useful to the telecom service provider to carry out evaluation of their existing deployment, right? And not to rely just on the costly commercial tools. So that is also one more area where open source community is helping.
Great. Well, thanks for pointing that out for us. That's great. Thanks, AJ. Final question to you all then. This is expensive. Of course, an expensive property. How can operators future-proof their mobile core network to avoid any future rip and replace expenditure when we get to the next generation of mobile? There's always a next generation of mobile, and it's always an extremely expensive and capex intensive process. José Antonio, is there anything about what we're doing now with our SA core that is going to help this situation, maybe prevent the levels of further expenditure every 8-9 years?
Yeah, well, we don't really know how, for example, 6G architecture will be defined, but 5G SA is being introduced based on microservices, based on containers, and the SBA architecture is based on APIs. So we expect that the future generation will take this architecture as a base to adapt new features, and actually the introduction of new features will be easy because you just need to include new containers, new microservices, or to develop new APIs to support new capabilities. So we really think that the future generation will take advantage of this architecture. And furthermore, we are completely defining the 5G core in a way that the software is completely agnostic to the underlying infrastructure. So we are working a lot on multi-cloud environments with a software that is able to be deployed in the public cloud, in the private cloud, or in hybrid environments. So we think that with this architecture, it will be easier to introduce future generations of mobile core, and we will take advantage of the current investment in the core solutions.
Great. Thanks, José Antonio. Amith, if I can come across to you, is this something you also hope for? That, it's early days in 5G, isn't it? We're still at the very start. There's a long life ahead for 5G and the underlying technologies. But are you looking for less of a hardware-based evolution and more reliance on software to upgrade as we move forward?
Yeah. Exactly. So I think what's been great is that the current, incumbent core providers, which we use a lot of, their solutions currently are, converged 2G, 3G, 4G, 5G, and 5G standalone via software upgrade. So currently it's a converged core on with non-standalone, but it's a software part to standalone. So that's great. I think also the fact that it's cloud native now and the ability to host it, in a public cloud or in your telco cloud, it makes it a lot more comforting. And I think, as mentioned by my colleague earlier, 6G, fortunately, there's a lot of drive towards ensuring 6G is not a complete rip and replace. So, functions like the NGMN, etc., are driving the fact that it should be pretty much software driven as well. And because of the service-based architecture, I think we have a good level of confidence that it wouldn't be too disruptive in the future evolutions of mobile.
Thanks very much, Amith. And Ajay, how can we make it more cost effective for operators?
So, yeah, I mean, till now we have been talking only about the 5G core network, which is good sign. We have seen that 5G core network now moving from the traditional hardware to the off-the-shelf commercial hardware. We can just install the 5G core on that. But look at the other side. There has been some good move on the RAN side as well. There has been a virtualization of the RAN components. So now, if you really see the whole Open RAN and ORAN, right, only thing what is probably will left on the real hardware is the RU part. So there is a good trend getting set here is that most of the things, the moment they become virtualized, we can use it run it on the standard hardware, right? So I'm more hopeful that we'll see a lot more adoption on the Open RAN side, as well as more adoption on the cloudification of this 5G core network. So overall, looks like we will have a lot more better integrated solutions in the 6G onward, and operator will have to spend less money into upgrading their network. But at the same time, I want to say that it's never a cutoff of moving from 4G to 5G in one day. There's always a time when operator has to maintain multiple networks simultaneously. And that's where it becomes a lot more tricky and a lot more investment, a lot more intense investment is required from the operator, right? So how fast operators can obsolete the older technology and migrate their customers to newer technology, that is also one area which needs to looked at.
Great. And Ajay, if I could just ask you a quick follow-up there. The amount of work that goes into this, it's a very technically complex process. Is this one of the factors that maybe there's a perception that it's not going as fast? This transformation isn't happening as fast. You talked about the RAN there. Great example. Lots of innovation, a lot of interest. It seems to be moving faster, certainly, than the core is. Is it all down to technical complexity where we might have this slightly slow-moving evolution?
Yeah, I believe so. It is see, most of the core network, they come with some sense of key parameters. There has to be the network has to work reliably. That's the primary responsibility for any operator, right? So many of them might be using it as of now just as in a smaller way, in a small scale, right? As the technology matures and operator gets more confidence, they will migrate to the newer technology. But that's going to help them to reduce the cost. But at the same time, we should not forget that they have to adhere to all the standards or the regulations imposed on them by the local governments.
Yeah, thanks very much, Ajay. And Amith, let's come across to you for final comments for this panel.
Yeah, I think one of the important points is the core network is the heart of the network. Now, the challenges that we see and the complexity is that you have a whole lot of bespoke billing systems or various billing systems, various RAN providers, and making integration with an open core a little bit difficult, because sometimes some of the BSS systems have some sort of proprietary interface, and so we have to think of it as a holistic, let's say, picture. And so again, capex investment starts looking a little bit higher than one expects. Secondly, in emerging markets, we haven't had the luxury to be able to switch off 2G and 3G. 2G will still be a little bit around a little bit longer. And one of the challenges with the open core at this stage is that their focus is on 4G and 5G largely. So bringing in some of the complexity, which we think will slow down a lot of the uptake in the emerging market space. Obviously, for private networks or B2B networks, etc., it can be considered. But for mainstream consumer applications, it will be a challenge.
Yeah, great. Well, some great points there, Amith. Thanks very much for bringing those into the conversation as well. We must leave it there, though. I'm sure we will continue this debate during our live Q&A show later. For now, though, thank you all for taking part in our discussion. If you are watching this on day 2 of our Open Telco Infra Summit, then please do send us your questions and we'll answer them in our live Q&A show, which is coming up very soon. And don't forget to view the other panel discussions and keynote interviews in this year's event. Here's the agenda for today, and the full schedule of programs and speakers can be found on the TelecomTV website, which is where you'll also find the Q&A form and our poll question. And please download our exclusive Open Telco research report from my editorial colleague, Rayla Matra. For now, though, thank you for watching and goodbye.